Now to find the length of an arc. So we're looking for the length going along the circumference between 2 points, say here A and B. Now let's go back a step. Our definition for the size of any angle in radians, we said if we're looking at the size of an angle, it's sort of like any angle can be made by opening up two arms. And if we let those two arms be radii of a circle and place the 2 points at the end of those radiuses on a circle, then our definition for the size of an angle in radians was that the size of the angle would be equal to the length of the arc divided by the radius of the circle. So this is central to our whole understanding of what radians really mean. So we can actually now rearrange this really simply to get the length of the arc by itself. All we need to do is multiply both sides by the radius, and we'll find that arc length is equal to radius times theta. But theta must be in radians, otherwise this won't work. So this is an important formula that we need to learn. Put it in a box here. I think this is on our formula sheet, so you can refer to it, but it's a handy one to know. So let's look at how we use this. Let's use our drawing here and 2 example questions. If theta is 120 degrees and the radius was 6, find AB. Well, let's use this picture. We can label these as 6 and go ahead and first, with our 3-step working, we always write the formula first, then we sub into the formula, then we get our answer. That way, you're really thinking about what you're doing right from the start when you write that formula down, and the more times you write it, it'll stick in your head and you'll remember it. So what we know here is that we're looking for L. We know what R is, 6, and we need to write the angle in radians. Now, if you need to figure this out on the side, go ahead in the margin and write 120, because that's your degrees, multiply it by pi on 180, because that's your conversion factor, and you'll see that the degrees cancel out, and a little bit of cancelling there, and what we've got is 2 pi on 3. You could also just think that this is 2/3 of 180. You could put 120 over 180 into your calculator. You can also just become very familiar with this. As we move along, this will get easier and easier. Now we can see that we've got 6 2s are 12 divided by 3. What we've got here is 4 pi as a length. Now you could leave it like that. It's a nice exact answer. You'd want to put some units on it though. We're dealing with centimetres, so we have 4 pi centimetres. And if they've asked for it to 2 decimal places or something like that, or you'd like to actually just go ahead and calculate it, just work out 4 times pi, and you're there. Let's say it's roughly 12.57 centimetres to 2 decimal places. All right, our second example asks the question another way around. It says, if we know that AB is 100, so up here on our diagram, let's now label this as 100 metres, and we know theta is 3 pi on 5, what would R be? Now, same method, start by writing your formula. L equals R theta. We know the arc length is 100, put that in, and we know that theta is 3 pi on 5, so we've got R times 3 pi on 5. Now here's where you could get a little bit mixed up with your algebra, so there's a bunch of ways to move on from here. You could say, well, I've got R times 3 pi on 5, so I need to divide both sides by 3 pi on 5. So R would be equal to 100 divided by 3 pi on 5. Now we know that that's the same as multiplying and flipping. So what we get then is R is equal to 500 divided by 3 pi, and that's metres. Now, working out what that comes to on your calculator is quite simple. 500 divided by 3 pi is equal to 53.05 metres. Metres, and then I write there 2 decimal places. Now, anytime you've finished a question like this, always refer back to your picture and think, does that make sense? Because if you've made a mistake, it might be out by quite a lot and it'll be obvious. So if this is 100 metres and our angle 3/5 of a pi, well, this is not too far from being out of scale. It's roughly right. The radius of 53 sort of makes sense. It seems pretty good, so I'm happy with that answer. Other ways of dealing with this down here, you could literally put this into your calculator right at this stage and you'd be fine if you're not happy with multiplying by the fractions.